Hey everyone, and welcome. Have you ever really thought about what's going on inside the apps you use every single day? Well, today we're going to pull back the curtain and take a look at the invisible architecture that makes everything work. And, what happens when it doesn't. Let's dive in. I mean, we've all been there, right? You're in the middle of typing a message, or you're about to beat a level in a game, and suddenly the app just freezes, or it gets super slow, or it just crashes completely. It's so frustrating. But it turns out the reasons for this are actually way more common and a lot more relatable than you might think. So, to really get what's happening, let's try a little thought experiment. Let's stop thinking about software as some kind of magic and instead start thinking of it like a house. Seriously. Because just like a real house, an app needs a solid design, it needs regular maintenance, and yeah, sometimes it needs a really deep clean to keep things running right. So, first up, let's talk about keeping that house tidy. You know how a cluttered, messy house is just hard to live in? Well, a messy program is just as hard to run. When developers talk about performance, a lot of what they mean is how tidy the code is and how well it's managing all its stuff. Okay, so a really common problem, a big source of mess, is something called a memory leak. Now, think about it like this. A lot of programming languages like Java have this amazing automatic garbage collector that goes around and cleans up memory the app isn't using anymore. But sometimes the program accidentally hides a piece of trash, so the garbage collector just walks right past it. And this quote from a Reddit user just nails the feeling of a memory leak perfectly. It's like letting dirty dishes pile up in the sink. At first, it's just one or two plates, no big deal. But over time, that pile gets bigger and bigger until you literally have no clean dishes left and your whole kitchen just stops. That growing pile of digital dirty dishes eats up all the available memory until the app slows to a crawl or just crashes. Another way our digital house can get messy is through what's called inefficient code. So imagine you need to tell the computer to do something. There are usually a whole bunch of ways to write those instructions, but some are just way, way faster and better than others. Inefficient code is basically choosing the longest, most complicated route to get somewhere when there's a super fast highway right there. A classic example is how some code combines pieces of text. One way is like carrying your groceries in from the car. One single item at a time. It's slow, it's clumsy, it's a ton of wasted effort. A good programmer knows there's a better tool, the string builder, which is like using a big shopping bag. You get the exact same job done, but it's so much more efficient. So why does this happen? Well, a lot of the time, it's a shortcut to get something done fast, to hit a deadline, with this promise of, we'll go back and fix it later. Okay, so we've tidied our digital house. It's looking pretty good. But where does the house keep everything, right? How does an app remember your progress in a game or save the document you were just working on? Well, this brings us to the next big topic, the filing system. At its heart, this whole process is called file input/output, or I/O for short. It's just a way for the program to talk to the computer's storage, its digital filing cabinet, if you will, so it can save information and then pull it back out later when it's needed. And this library analogy is honestly the perfect way to picture how programs find data. It's not a random search. Just like you'd go to a library and use the card catalog to find the exact book on the exact shelf, a program uses a very structured system to locate the precise piece of information it's looking for. And this process follows this really nice four-step dance. First, the program asks the computer to open the file. That's like checking out the book. Then it can read from the file, or it can write new things to it, kind of like adding a little note in the margin. And finally, and this part is absolutely crucial, it has to close the file. That's putting the book back on the shelf so somebody else or another program can use it. So our digital house is tidy, our filing system is perfectly organized, but modern houses are busy places, right? There's always a lot of stuff happening all at once. Well, the same is true for software. And this is where things can get really interesting. This concept is called concurrency. It's the software's amazing ability to basically walk and chew gum at the same time. While one part of your app is maybe downloading a big file from the internet, another part is still letting you scroll and click on buttons. It's what makes modern software feel so incredibly fast and responsive. But what happens when two parts of the program need the exact same thing at the exact same time? Well, you can get into a situation called a deadlock. Just think of it as a digital traffic jam. Two processes are completely stuck, both waiting for the other one to move, and because of that, everything just grinds to a halt. The app freezes.
Okay, to really get this, let's picture a super simple scenario. Imagine two people meeting in a hallway, but the hallway is so narrow that only one person can get through at a time. Program A needs to get past Program B. Simple enough.
But here's the problem. Person A is waiting for Person B to move out of the way, but at the same time, Person B is waiting for Person A to move first. Neither one can go anywhere. They are stuck in this polite but permanent standoff. That is exactly what happens inside your software during a deadlock, and it's why the program just stops responding. Whew! Okay, we have covered a lot of ground today. From kitchens filled with dirty dishes to people getting stuck in hallways. So let's do a super quick recap of these big ideas using those analogies that make them so much easier to remember. So, a memory leak. That's our growing pile of unwashed dishes that clogs up the whole kitchen. Inefficient code. That's like making 100 trips to the car instead of just grabbing a shopping bag. File handling is that organized, sensible process of using a library catalog to find your book. And a thread deadlock, well, that's that super awkward moment when two people get stuck face to face in a narrow hallway. And that's really the main takeaway here. What makes an app truly great isn't just the flashy features you see on the surface. It's all the thoughtful, invisible work happening behind the scenes. The smart design, the careful management, the elegant solutions to tricky problems that keep it running smoothly. So that leaves us with just one final thing to think about. Now that you've had a little peek inside the house, how might you see your own digital world just a little bit differently? Seriously, think about it. The next time an app updates on your phone, it might not just be adding a new emoji or changing a color. It could be plumbers fixing a tiny memory leak, or electricians rewiring some inefficient code, or a whole team of organizers doing a major spring cleaning. It's a great reminder that our digital houses, just like our real ones, always need a little bit of care and attention. Thanks for joining me.